Morning, everyone. I'm going to be talking on data cleaning on text to prepare for machine learning or for doing other things with text. And really, this is a wonderful excuse for me to complain to you about the difficulty of working with text and all the challenges I've had over the last 10 years. So you get to listen to me whinge. So I'm a past speaker at a lot of Python conferences, PyCons, PyDatas, EuroPythons, and I co-organise the PyData London event meetup in London. So every month we have about 200 people meeting up to talk about data science. If you're at all available to come into London, I'd love to have you along. We have a really rich and vibrant community there. I also wrote a book on high-performance Python for O'Reilly last year. And so Deirdre then stuck one of these I like to talk about stickers on me, so I like to talk about HPC and data cleaning as well. And I hope you will all wear your I like to talk about stickers. Right, I see, yeah, good. So that we can encourage more conversation and share some more knowledge here. And as I note up there, I clean data sci. So I'm a data scientist. I'm a self-proclaimed data scientist. That means that I know a bit more stats than my fellow engineers, and I know more engineering than other statisticians. So I make up stuff that sits in the middle of that ground. Really what this means is I spend a majority of my time doing data engineering and data cleaning to try to turn horrible, messy data into something halfway useful. And I've made a lot of mistakes in the last decade, so hopefully you can learn from some of them and get forward faster. So we live in a world of unstructured data. There's an increasing amount of unstructured data. There's this huge outpouring of unstructured data from all sorts of sources, both human-generated like Twitter and Facebook, news organizations, spam bots, and semi-structured data coming out of the Internet of Things. I've got a Withings internet-connected scales, which is recording the CO2 in the house every day and putting those readings out along with weight and everything else. And we're all getting more used to putting out a data exhaust via our phones. So we have this increasing pool of unstructured and semi-structured data coming out, and we want to exploit it and do stuff with it. Hopefully stuff that benefits mankind, at least stuff that makes money if you're running a company, or maybe stuff that just makes the world a better place. But you've still got to work on joining this stuff together. So it's hard to extract the data, it's hard to parse it into something more useful, and it's hard to join bits together. And so I'll talk a bit about each of these. It's a very valuable thing to be doing, so I've been running a consultancy for 10 years. My current client is Elevate Direct. So this is a contract recruitment outfit where they realized that sooner or later someone was going to automate contract recruitment. So rather than waiting to be put out of a job, they decided to make the IP such that they could sell the company and put themselves out of a job and get rich in the process. So I run their data science department via my consultancy. There's a couple of us working on this. Really, it's a dating site for contract jobs and contract roles to be put together, and it's done via scraping in PDFs and Word documents of people's CVs that are posted online, extracting all of that raw data. So you say you've got .NET, the client says they want C#. We know those two things are related because they come out of the CVs. They're expressed frequently enough in CVs on the same job that we know that those two skill-like things are related in some way. And then we pull that out to rate people for jobs based on experience and companies, the amount of time they've had, which country they're in, and join it all together. And the recruitment industry, if you'd have asked me 2 years ago would I work with recruiters, I would have laughed at you because nobody likes recruiters. But it turns out it's actually a very valuable part of the economy, and it's rubbish. It's really poorly handled. So the idea of automating it with some NLP feels like a very valuable way to get rid of some of the rubbish in that industry and make the process more streamlined and less painful. So one of the first things we have to do is extract data from PDF documents and Word documents. There's a couple of free tools that do this. Textract is a Python wrapper around a number of open source tools that lets you pull data out of a number of sources: images, text, images, audio, videos, and particularly different text formats, Excel documents, all sorts. It's pretty good. There's a better one called Apache Tika. So this requires some kind of Java bindings like Genius into Python, but it does have better support for extracting raw data out of packaged document formats. One of the main problems is that certainly Adobe Acrobat PDFs It's a layout standard, not a consumption standard. So every character is positioned in the document at an exact place, but the characters don't know that they're connected to the characters before or after them. You just happen to have characters that are more widely spaced than others, and that tells you you've got a word break, or maybe punctuation, or maybe a line break. And you have to guess how these things all join together. So you pull out the raw data and you get a collection of characters, not words, not sentences, not paragraphs, and you have to try and do something with it. And certainly there's no semantic interpretation of that raw data. And when you're dealing with things like CVs, you end up with all the stuff we used to see on the web. So you see keyword stuffing with white keywords on a white background, trying to increase the relevancy of a CV in somebody's search. So we have to deal with that kind of thing. Thankfully for us, there's a couple of commercial parsers. We use one called Sovereign. It's pretty good. It's a .NET-based product. It extracts a fairly good representation, but I don't know of any others. And it's something that for various domains is sorely lacking, I think. Certainly open source semantic markup around raw data sources like PDF documents. In the academic world, there is the Sermine PDF paper parser, and that can extract, say, the list of references, the abstract, the title. So that's quite nice. That uses machine learning and text parsing to try to pull out some structure from these otherwise sort of semi-structured documents. But I don't know of any others. Certainly if you're working on any or you have experience of any of these, I'd be very curious. I'm just always curious about how we add more layers of structure to unstructured data. So please tell me if you know of other tools. Lots of PDFs contain tables. I don't care about this for the recruitment side of things, but for academic papers, this is a huge problem. We have lots of tables, and for government reports, lots of tables. If you try and extract that data, you get lists of numbers, maybe with commas, maybe without commas, maybe all joined together, maybe a whole table joined into one long line of numbers with no spacing between it at all. Trying to interpret that that's a 10 by 20 table where different columns have different data types is really, really hard. So there are a couple of tools. PDF Miner is an open source one. ScraperWiki have PDF tables. They've enhanced their PDF Miner. And this tabular, it requires some kind of human intervention. You have to define some of what you see in a PDF document, but it does a pretty good job of extracting the data and formatting it and cleaning it up for you. And there's another tool, Messy Tables. It uses PDF Miner, but it seems to have better support for things like CSV files and HTML, where it can pull out the columns that it sees and try to mark up the data types. In each of those columns, it has strings, integers, and floats. So that feels pretty useful. Maybe there are other tools. I've not come across them. Again, if you know of any, please let me know. Fixing badly encoded text is huge amounts of fun. Oh yes, it really is. And it happens all the time, and it's a right waste of time. So maybe you're expecting to see Sean, and you see an A with a squiggle. That's a very common misencoding. I think that's Windows CP 1252 encoded, but decoded as UTF-8, I think, in that case. It's one of the very, very common mistakes you see. And then the M dashes. So it turns out there are 5 obvious hyphen equivalents. Actually, there's about, I think there's 20 or 30 dash-like Unicode symbols in total. They all render pretty similarly, but if you're doing an ASCII, if my string equals, quotes, hyphen, it will be wrong most of the time. When people do pretty printed PDFs, then they come out with M dashes and N dashes and many others, so you have to kind of normalize for that kind of stuff. But just decoding it so that you've got something you can normalize in the first place is a bit of work. And web scrape data, things like the @ semicolon, you have to do something like HTML unescaping for that. I'll talk in a moment about the Turkish 2i problem, which has a tragic story attached to it. Character encodings are often missing on text files when you try to load them in. So if I load in a million lines of UK government open data for the land registry, so the house sales for a year, most of the file loads in, then it blows up in pandas with a Unicode decode error with no clue as to what the error is, where it occurred, or how I go about fixing it. If I run it through chardet, chardet will try all sorts of different encodings on every single binary line that it reads in, and it will come up with what it thinks is the best decoding to use that will work for all of the lines. It takes a little while, but in this case it tells me it's Windows CP 1252, and it's something that will be nice to see in something like pandas. But just knowing that you can let the machine solve this problem for you, rather than you trying to decode a million lines by yourself to figure it out, yourself. That's quite nice. Who knows the Turkish two eyes problem? Anyone come across this? Oh, okay, a couple of us, excellent, right. There's a few of us who have shared this pain. So there's a couple of problems here. We all know the world is full of wacky alphabets. ASCII could be the one that rules them all, but sadly we have to accept that people have funny squiggles on their names. There's a joke, it's not a very funny joke, but it's a joke in the office, that we really wish everyone just had uppercase ASCII for their names, because that way that would solve so many of our problems. The Turkish two eyes problem is that you have a capital I in Turkish with no dot on it, and the lowercase variant with no dot, and an uppercase I with a dot, and the lowercase variant has the dot. In English, you have an uppercase I without a dot, and a lowercase I with a dot. So you can't easily convert between them unless you know that you're dealing with Turkish. You could use, for example, the Chromium Compact Language Detector to figure out which language you've got. But if you haven't got that, then you've got this problem. And this occurs in all sorts of different languages. In Irish, for example, you can use lowercase i's with and without dots, and it doesn't really matter. So you couldn't tell whether you've got Irish or Turkish, say. This story is tragic. So phones in Turkey don't, or at least didn't, in 2008 have very good Unicode support. So this couple are divorcing. They've got acrimonious text going back and forth. A text gets sent by the husband telling his wife that he's really grumpy with her. She reads it, and by looking at the word where the I's have been represented poorly, she interprets it very differently. She shows her father. The father is incensed. He cannot believe that the husband has called his daughter a prostitute. And he's massively angry. Of course he is. The husband turns up to apologize. The husband gets stabbed by the father. He wrestles the father off, and then the wife takes the knife and carries on. He wrestles the knife off of the wife and stabs her instead and escapes. Shortly afterwards, there are two people who are dead. So that's pretty tragic. Why is it tragic? It's tragic because our industry still is pretty rubbish at dealing with Unicode. So that's the simple case, right? I've spent a bunch of slides explaining to you that decoding Unicode and byte encoding is a pain, and people die as a result, or at least people have died. Not many, it's an extreme case. If your results matter, if, for example, you are publishing a paper and you know that you're going to be required to publish your code and your data, and you expect that you're dealing with text and you're going to get away without worrying about the quality of your data, please think again, because probably, almost certainly in my experience, your data is going to be rubbish, and this kind of thing will bite you. We have no tools at the moment to interpret data types on, say, a pandas data frame. If I load in a plain text source like a CSV file, I can look at it and eyeball and see that I've got two types of value in one column, say male or female. That could be a binary indicator. But nothing tells me that. I have to do it by hand. Maybe I've got mixed weights and measures. So if I've got centimeters and inches and meters in the column, nothing tells me there's all a measure, and we could normalize this. In the astrophysics packages, we've got good ways of normalizing between different units. I don't know of any that recognize the units automatically in text and then offer a standard encoding, say moving to metric. Date parsing is always weird and wacky. The tools are mainly made by Americans, so they assume an American convention, month, month, day, day. If you pass in two columns of numbers which are in day, day, month, month, then normally it's back to front for the first 12, because it assumes it's month followed by day, and then for 13 onwards, it realizes it can't be month, day, so it then decodes it as day, month, which means that 2/3 of your data is flipped around the wrong way relative to the other 1/3. And none of the tools, pandas, none of them will tell you that this is a problem. It just goes wrong silently. Much hilarity ensues. Day first equals 4 solves that problem if you know that that's the case for your data. Maybe someone with some spare time would like to write a couple of tools that check our data frames and spot possible binary indicator columns, columns containing weights and measures that could be normalized, date times that appear to be behaving in a really weird way, and then offer some suggestions. That would be super useful. And I think we can go even further than that and look at automated feature extraction on text documents. So looking for products and room numbers and category types in columns, or Boolean equivalents, anything that removes some of this legwork to make a junior data scientist problem, a PhD's problem, a master's degree student's problem of interpreting text easier is going to be a massive win for the community. And it's just something that I'd love to see. And I have this sneaky suspicion that we could do something around automated validation of data. So if I've got 1 million lines of data from the land registry for house sales in 1 year, and I extract the primary address object name field. This is the field that tells me what the house number is. Typically it's a number, sometimes it's text, like flat 20, house 2, and sometimes it's a none value missing because there's no number. And I can plot out a distribution of if I just encode all the numbers as an integer. If I've worked on one data set and it looks like it's a pretty solid data set, I've worked on the 2014 data, I get the 2015 data. I'd like to ask the question, without spending a lot of time validating this data, is the distribution of data in the 2014 set the same as it is in the 2015 set? So, are the numeric ranges roughly the same? Is the distribution roughly the same? Is there the same proportion of nones to valid rows of data? If there is, great, I've probably got the same kind of data. If there isn't, I just want to know because probably someone's gone from encoding data in integer format to having a leading 0, so it looks like hex, or they've swapped it to be a string field, or they've flipped over some data types. Anything that's really wrong, I really want to know about quickly, but I don't want to have to go and figure it out myself. I really want the machine to tell me. I can solve this for some of my challenges, but before I have a go at making a general tool, I'd really like to hear about your kind of use cases for how you do validation of new data sets relative to ones that you already trust. I'd really like to hear your experiences and the domains that you're doing it in. There's a note there about infinity. I was surprised that the standard deviation of my data was infinity. It turns out there is a building on the south coast with 20 flats in it, which is called infinity. So mp.float on house number, and I get an infinite result. The data, of course, has stupid distributions or weird distributions, unusual distributions. These are the first 50 house numbers. You see a strange notch at 13. 13 is an unlucky number. Of course it is. It's unlucky enough that some boroughs in the UK ban houses having the house number 13. So we see this weird notch. So every distribution is different, of course, but the number of 13s in year 1 and year 2 are going to be the same relative to each other. So I reckon we can check that easily. Merging two data sources is the key way to take two different data sets and join them together to get added value. In an SQL table, you just merge because you've got a nice clean key field. With text data, you often don't have a nice clean text field. So if you've got that clean text field, you can do a pandas merge, but otherwise you need to do cleverer things. You can do it by hand with tools like Fuzzy Wuzzy, which does things like a Levenstein error distance, or Metaphone gives you a phonetic spelling, so it normalizes away the different variants in spelling to give you the way that it's pronounced. And DataMade's dedupe tool is really quite nice. The idea here is that you take a CSV file with many repeated rows inside it, just because it's bad data quality, and you learn some heuristics with an online active learning process to figure out which fields and which metrics help you identify the duplicated lines, and then it can strip out the duplicates for you. So that feels like a really useful tool for getting rid of duplicates, but also for merging between data sources, which it doesn't really support at the moment. And I'm curious to know how you've gone about dealing with merging difficult data sources together. There are lots of ways of doing manual normalization. I won't obsess over this thing as I'm running a bit low on time. Lots of unit tests is one of the main keys here, and I'll post these slides up after the talk, and you're very welcome to ask me questions if you've got thoughts about this. Halfway down, I note the non-breaking space. There's about 20 invisible white space characters. They've all got slightly different spacing, so if you search for a space, but you've ingested data from a Unicode source, there are 20 different things you should be checking for. I've already mentioned the dashes. There are lots of these kind of things. There's a nice tool called UniDecode, which gets rid of all those pesky accents. It doesn't get rid of all the variants in spacing and hyphens, but it does get rid of a lot of the plain ASCII variants, which is quite nice. I'll get to that in 1 second. About a year ago, I wrote a tool called Annotate, which I promised myself I will have open sourced it by the end of the day. I hit upon the idea a year ago that after 10 years of writing manual normalization processes, I was really bored of doing that, and why couldn't I let the machine do this for me instead? So here's an idea. I've got the data on the left, that's what I've got. I've scraped this off of some web source. I've got data on the right, which is what I want it to be. And then I have to figure out the regular expressions and the parsing and the UniDecoding and whatever else to do that transformation. Instead, why can't the machine figure that out for me? So I wrote myself a tree expansion routine of all the common operations I would do. It makes a horribly large tree, but within a couple of minutes on the data sets that I've put through it, it finds a valid combination of operators such that it converts what I've got on the left to what I want on the right. This feels like a useful idea. So the example on the right there, I downloaded salary data for data scientists in London and in the UK from import.io. So this is the job of a data scraper person, not an engineer necessarily. I got the data down in CSV format. I then push it through the RESTful API that I put here. I've got this, and this is what I want. Gave it a couple of hundred examples. In fact, I gave it tens of examples that I'd manually marked up, and it found the right transformation such that I could then graph the result afterwards without doing any regular expressions myself. So my implementation of this tool is pretty cruddy, but I think the idea has value. And whether it's this tool or another one that goes on to be the thing that we need to transform our data, I think this is worth exploring. Because if so many data scientists spend so much of their time fudging their data to make it work, that's just a waste. And I reckon we can have the machine do it for us. There are many representations of Null in the last project I worked on. We had none values and empty strings and strings with an encoding that said it's a none value and a binary object which encoded zeros to represent none. So 4 different ways of representing none. It's really stupid. Just have one. Don't let many sneak in. And have a schema checker which can check your data for you to validate that you've got the kind of data you expect. It's the only sane way through it. There aren't many tools for visualization with text data. A relatively new kid on the block is GlueVis. It's quite nice. You can put in numeric data sources or categorical data, and it will graph them a little bit like Seaborn does, which is quite nice. And if you start highlighting data in one of your columns, it will highlight the linked data in the other columns that you've shown up. So it's a really nice data investigation tool. Not designed for text, but it can work with categorical data. But there aren't many other good tools. The Cito's CSV fingerprint gives you like a 1,000-foot view of your data, but nothing more in-depth. I'm really curious to know what kind of tools you have for working with natural language data. Please let me know, because visualizing it is the easiest way to communicate with your colleagues what's going on. And there are lots of ways to augment your data. So Alchemy lets you recognize sentiment and entities, so you can bring in higher quality features into your data based on whatever raw data you start with. dbpedia lets you recognize entities. You pass in a string and it tells you which things from Wikipedia it's already found. You can also query dbpedia manually. So if you take a Wikipedia URL, so wikipedia.org/n/Barclays, and you go to dbpedia.org/page/Barclays, it will tell you all the triples it has of knowledge. So it will tell you the number of employees at Barclays and company, date founded, and a date. And if you go to the /data/Barclays JSON, you get a JSON queryable view instead. So you can start interrogating just with, say, the requests module, which is really quite nice. And of course, you can use tools like NLTK and the newer NLP variant Spacey that's about a year old and is much faster than NLTK for this kind of thing. So, tiny bit of advice just to wrap up with. So I just started another text classification project in fact, yesterday in the office, just to find out if I can get any useful information out of my data at all. I start with a count vectorizer for binary features, so is this word present or absent, and a Bernoulli naive Bayes classifier. So I can just start to say, can you classify this versus this? If it's better than 50-50 on a balanced data set, then happy days, I've got something there. Maybe I can go on to a logistic regression, and I did, and I get better results. But rather than going for the more advanced, more complex classifier, start with something really, really simple. Something where you can pull it apart and look at the numbers in there, look at the vector representation of the data that's going through each stage of the classifier, right from the raw data, where you can diagnose the whole process and just eyeball the whole thing. Always favour better data and better features over having crappier data and a better classifier. It's way easier to diagnose your problem if you've just got good features and good clean data, which is why I spend so much of this talk talking about how you can clean up your data and not start with mess in the first place. And always remember to diagnose what's going wrong at every stage in the process. If you start cludging failures with more complexity, things aren't going to work out in the long run. It's not going to be supportable. It's not going to be a great published result. If you can diagnose it from every step through, then you're in a pretty good place. So closing, I'm really curious to know about this idea of annotate, which I will open later, for transforming data I've got into data that I want. It works on text data, but it could work on other data. I'm curious to know how you might use it and how it might save you time. I want some dirty data horror stories. These are problems that I intend to be working on more. I'm bored of doing this stuff by hand, so I want to automate it. I'm kind of inspired by Peter's project. I know I've left pull requests for too long in the past, and I quite like the idea of just starting to accept everything and seeing which these projects work out. And finally, I've got a keynote to give in 6 weeks' time in Budapest. What is, for any of your projects, data science or whatever, what are the hard problems you have from initial conception through to delivering working things? I've got lots of commercial stories. I haven't got many academic stories. So I'm curious to know what kind of problems that you have that I could include there. All right, thank you very much.
So, thanks, Ian. There is the short time for questions. So, the audience.
Hey, great talk. This might fall under the using tools that are too complicated, but have you tried using the document vectors from the awesome Jensen package on CVs to see if you could find like similar CVs? I've used it on data which I thought there was no way it could reasonably work on, and I got meaningful results out of them.
So I haven't tried doc2vec yet. We have worked on word2vec, and with word2vec you can do things like, so with a corpus of a couple 100,000 CVs that we're working off, you can begin to ask, I forget the exact question, but I don't know, programming language minus Windows plus open source gives you Linux or whatever. These kind of questions worked out reasonably well. And I was surprised that that kind of result came out of just CV data by itself. But no, I haven't used doc2vec yet.
In this case, I mean, if you're interested in CVs of similar people, it might find people that have similar CVs.
So it's not just, is their text representation the same? It's also, how many years experience do they have at which points in their careers for the appropriate company that my client is interested in, and the skills that they mention. So you have to start having a modeling of the time ranges and the history related and some kind of weighting function behind that. So it's a bit more than a pure text similarity.
Else?
Hey, thanks for the talk. Yeah, so machine learning claims. I'm not saying it's true, but if you give me a big enough training data, I can solve the problem. So I'm interested in knowing whether a lot of these like data messaging problems could be solved this way. And I can't answer this question because I don't have a training data set. So, I mean, that would be interesting.
What are you asking?
Could we pitch this as a machine learning problem? A lot of these like a data conversion, data messaging problem.
Right.
And to do this, we would need a large training data set to learn all those transformations.
Right.
And because as you point out, it's terribly time consuming to write all these things.
Yep.
So if we were able to like get a bit more process in there and automatize it, it would be awesome.
It would be awesome, and I would love to not have to do this stuff by hand anymore. So yeah. I believe we can automate a bunch of this.
So if there is one last question before the break.
Or it could just be coffee time.
Yes.
So,
Have you used Elasticsearch on the new significant terms?
So we do use Elasticsearch. If we're doing pure text queries, which is the previous generation of the software, that works great. If you want to know, for my messily formatted date field, whether the person had .NET, and actually they only wrote in there they have Microsoft Technologies, it doesn't know that association. It's never going to figure that one out. So we have to clean the data up. Once you've cleaned a lot of it up, you can do these kind of queries, and actually we have our scoring mechanism as part of the scoring engine inside Elasticsearch. So we can query 300,000 CVs in the blink of an eye because it's distributed and it's all inside ES. But you have to work those metrics out externally, and we prototype all of that in Python.
So please, next session speakers, test your laptop before the session. We are back at 11 after the coffee break, and thanks, Ian.
Okay. Thank you.